Hi there, students. This class is about sample selection and sample size. Just to give you a heads up, it's a pretty difficult class, arguably one of the hardest classes this whole semester. So I encourage you to pay close attention, read the note pages, and definitely let me know if you have any questions. I'll try to go slow so that everyone can follow, but if you want to speed it up or if you want to, on the other hand, listen to it twice, you can customize it in that sense. So, of course, I divided up in several sections again, several sessions I call them, simply because listening to one super long train of me rambling about sample size is going to be pretty boring, so I'm going to chop it up. So, if you look at where we are in the semester, you can see we're already at step 8, determining sample plan and sample size. Again, like I said before, we're moving at a pretty good pace, but we're going to slow down when it comes to data collection and especially when it comes to data analysis. So in this online session, I'm going to cover different sampling methods. There's two main categories, probability and non-probability sampling methods. And then we will talk about 8 axioms underlying sample size determination with a probability sample. And then we're going to talk a little bit about computing sample size using a confidence interval method. I know all of this sounds exactly like you want to hear right now, but we're going to go through it. I'm going to make it easy to understand with lots of examples. So in this first session, I'm going to cover some basic concepts in sampling. The first thing, or the first concept you need to know, is there is such a thing as the population. And a population is basically the entire group of people that we have under study, the way you define them by your research objectives. So of course, managers who are not really trained in research necessarily, they tend to define the population pretty broad. They could say things such as, oh, everyone who uses our services or everyone who buys our products. And you know what the heck, even the people who don't buy our products. We include everyone. So that's a very broad approach when it comes to defining a population. Researchers tend to be a little more nitpicky in terms of how they define a population, so they use more specific terms. They could say stuff like, oh, all heads of households located in certain zip codes served by the company who are responsible for making purchase decisions. So it's much more specific because it makes research much more doable if you define your population more specifically. Now still, it of course completely depends on your research topic. So if you have this massive group of penguins right here in Antarctica, this would be a census. A census is the theoretical notion or the idea of capturing the whole population. So it literally means accounting everyone or taking into account everyone in the entire population. Now you might have heard of the word census in the sense of the US Census data. But even US Census data is actually still only 1% of households. It's not literally every household in the USA. That's because it's nearly impossible to conduct research among everyone in the population. Sometimes people's legal residence is not registered. Sometimes they don't even have a legal residence. So in a lot of cases, it's just impossible to do research among the whole population or among a whole census. That's why we rely on subsets of the population called samples. Here is a sample. Let's say this smaller group of penguins, these cool guys hanging out right here, that's our sample, and then a sample unit would be one of them. So that's one particular household or one particular person, a basic level of investigation in your research. Now, I'm going to throw a couple more concepts at you simply because for this introductory session, it's important you understand the basic words that we use in sampling before I can start explaining how they relate to one another. So now that you know what a census is, a population is, a sample is, and a sample unit is, there is also such a thing as a sample frame. By the way, there's a helicopter on the background. I don't know if you guys can hear it, but I'm not going to pause the video for it because I'm on a roll. So I hope it's not disturbing you too much. So a sample frame is basically a master list that tries to account for everyone in the population. So it's the best attempt you can get to capturing all units in a population. So think of, for example, Yellow Pages, which of course no one ever uses anymore, or think of, for example, your list of followers on Instagram. If your population is defined as everyone who follows me on Instagram, then how do you know who all follows you on Instagram? Well, let's go to your follower list. And that whole list that register, that accounting of everyone who's following you is called a sample frame. So this could also be in the form of, for example, employment records, school class lists, patient files in a hospital, organizations that list every member of that organizations, class rosters, and so on. So any list that literally lists everyone in the population. Now, what do you think could be wrong with that type of list? Such as the telephone book, the yellow pages, or an Instagram list of followers? Well, the reality is that since that is a snapshot, that is like a one-time way to capture everyone in the population, by the time you've literally taken that snapshot or printed out that list, people might have already left the list or be added to the list. That's how often units in a population change. Think of, for example, imaginary, if you have like an entire list of everyone living in the United States. Okay, let's say theoretically if you could put them all on a list. Well, literally by the time you've made the list, people have already moved out of the US and people have already moved into the US. So inevitably, when you have a sample frame, there will be an error because some people will not be included in the list, even though they are in the population, and some people will be included in the list but are technically no longer part of the population. So you have these false positives and false negatives pretty much, and these are called sample frame error. So that's the degree to which a sample frame fails to account for all of the population, because such lists are never flawless. Now that you understand sample frame and sample frame error, the next concept that is important to understand is sampling error. And sampling error is any error that occurs in research simply because you use a sample. So with any research you do, when you rely on a sample, which is pretty much always because we don't do research among the whole population, you will inevitably have some sample error. Now, where does this sampling error come from? By the way, we call it sample error or sampling error. That's the same thing. Where does this come from? There's two causes for the sampling error. First of all, the mere fact that you draw a sample, simply because if you draw a sample, you have to build that sample on a sample frame, and that sample frame comes with sample frame error. So as a consequence, you'll always have sample error. And secondly, the size of the sample plays a role as well, because the smaller your sample size, the larger your sample error will be. This is something we will explain in one of the next online sessions of this class. For now, keep in mind that sampling error is an inevitable consequence of using a sample, simply because samples are made based on sample frames, and sample frames are in themselves flawed because they have sample frame error. So this visualization helps you understand the relationship between each of these concepts. Imagine the blue circle being the population. So that's a theoretical idea. That's the whole population, but you can't capture the whole population. You're just trying to capture the whole population. And the best way to get to the whole population is collecting a sample frame or basically drawing a sample frame. So a sample frame is the closest possible approximation of including everyone. So it tries to overlap with the population neatly, but there's some sides, as you can see in the left lower corner, you see sample frame error. And sample frame error pertains to people being in the population, so people being in the blue field but not being captured by the sample frame, but also means people that are included in the sample frame but are actually outside of the population, so people that are in the orange zone but are not actually part of the blue circle, which is the population. So that's what I meant with these false positives and false negatives. You're gonna have sample frame error as soon as you use a sample frame, but you have to use a sample frame. There's no other way around it. Now, this sample frame forms the basis of drawing samples, right? If you have that list of people following you on Instagram, and let's say you want to take a sample of people following you on Instagram, let's say you have 1,000 people following you and you want to include 100 people in your sample, you can randomly pick 100 people out of that list, out of your list of Instagram followers. But since that list is flawed, you're consequently also going to have some flaw in your sample. And this is what we call sample error, like I said earlier. So sample error is the type of error that accompanies samples, that goes hand in hand with drawing a sample. And then the little yellow circle here is a sample unit. So that's one person in your sample. Okay, so I hope this overview helps you understand the relationship between these concepts. Now you might wonder, okay, we've been spending like the past couple minutes talking about errors. Why do we even take a sample if errors are so prevalent in research? So that's first of all because of practical considerations. We take samples because of the cost and population size. It's nearly impossible to do research among the whole population, and even if we would, it would be very costly. So that's why we take a sample. Now, the good news is that even small samples can be representative. So it's not even necessary to gather data from a whole population. A well-chosen sample, even if it's on the small side, can actually be representative. That's because sample size has nothing to do with representativity. Nothing. It's a misconception. A lot of people think that a bigger sample makes it more representative, but that's complete BS. Sample size has nothing to do with representativeness of your sample. Sample size has everything to do with accuracy, and this is something we will talk about in the next online sessions as well. Now, one thing that I did also forget to mention is another practical reason why we take samples instead of the whole population is because most statistical software programs slow down significantly when we try to analyze data from, let's say, billions of respondents. Usually, computer software programs operate optimally when you have limited number of subjects. So a census would just create a huge mess when it comes to analysis.